After discovery, as we typically do, we typically start collecting more measurements, more observations, and we quickly saw that the object was, let's say, having impact chances with the Earth in December 2032. Seeing that the impact probability that we are assessing has been changing from day to day, and this is the result of this daily update with new observations that we are collecting from either from our teams or from other teams that are observing also this object. So this is what allows us to redo every day the orbit determination process and redo every day the impact monitoring process that allows us to evaluate the impact probabilities on a daily basis. So the object has been estimated to be in a range between 40 and 90 meters, and we are trying to collect as many observations, not what we call astrometry observations, which are the ones that allows us to determine the position in the sky. Of course, we are doing that a lot, but we also want to collect measurements that allows us to determine the physical properties of the asteroid, which would allow us to determine better the size of the object, and we are still doing that. The impact velocity, which will be in the order of 17.3 kilometers per second at the moment of the possible impact, and the density of the object, which we don't know. So for that, we have to do some let's say estimates. But the let's say the amount of energy that would be released, taking into account those uncertainties, could range between 5 to 50 megatons. Let me tell you, the most likely scenario is that by the time we lose sight of the object in April this year, the impact probabilities will have lowered enough not to worry about this object anymore. However, there are still some small chances that it will remain in our risk list, and when we come back, when it will come back in 2028, and we reobserve it, at that time, it will have been so much time enough for us to determine whether, let's say, it will be impacting or not completely. So it will be a 0 or 100%.
And liftoff of the Falcon 9 and DART on NASA's first planetary defense test to intentionally crash into an asteroid.
Just heard the call out for spacecraft separation. You can see the video of the DART spacecraft heading on its way to the Didymos system.
What a spectacular view. of DART
Yep.
just floating away from the Falcon 9 second stage.
And you can see the sun off to the side there as DART drifts away from the Falcon 9 second stage.